In this video, I want to create a function that will count the number of nodes that we have on our list. This function will come in handy for a couple of reasons that I can think of. Number one is once we start adding nodes to our list and we get up into the hundreds or thousands, that data will give us an idea of how many nodes we have on our list. Another reason is we can start doing operations with our data. For example, if we want to add all of our data and get the average of that, we can use our count node function to divide that. So on the left side is our code, and on the right side, here I've copied our main, and this blank slate is our representation of our memory. So the first thing I want to do is I want to create a function prototype. We want it to return an integer. And let's name this function count nodes. I'm going to use the camel case notation. And we want one parameter. We want node pointer, and we just want to pass the head. And here at the bottom, I want to create a function definition for it, and I'm going to put it right after the print function because our count node function is going to be very similar, almost identical to our print function. The only difference is it's going to return an int. First thing we want to do is we want to handle the condition. So let me create an activation record for main. And inside of main, we have our head function or our head pointer variable. And let's just say this has an address of 0x50. And the first condition is what if head is pointing to null? Very similar to lines 96 to 99. But instead of returning the list is empty, we're just going to return 0 because we don't have any nodes. So if head is null, then return 0. And then otherwise, create a counter variable that we can store the number of nodes. So we'll just call it count. And then we're going to set that equal to 0. And then I also want to create a current pointer. And we're going to set that equal to head. And then after that, we want to traverse our list. So while current does not equal no. And before I come up with a definition, I want to explain the logic. On the right-hand side, let me draw this for you. After we execute the functions that we have in our main, our head is going to be pointing to our first node, which is address 0x300. So our head is holding that address. And then we create an activation record for, let's just say, we're going to call it here, count node, and then we're going to pass it the head. In our count node, we're going to have a pointer. We're going to have two pointers. We're going to have our head pointer, and that's holding the address of our head pointer in our main, so they're pointing at the same thing. And then we're also going to create a current pointer, and that's pointing at the same address as head. So while current does not equal null, well, note current is not null because it's holding 0x300. What we want to do is we want to increase the count. That means we have a node there that we can count. So we can add 1 to our count. So let's do that. So count, we can just do a count plus plus, which is the same thing as count equals count plus 1. So now we've counted this node. So what we want to do now is we want to traverse it to the next node. So we want to set current to this node. So this will become 200. We want to say current, set it to the next node. So assign the next node's address to it. So assign current arrow next nodes to it. And so it's going to point here. And then it's going to go all the way back to 122. And it's going to ask the question, does current equal null? And the answer is no. It's holding the 200. So now our count is going to increase. So when we were here, our count was 1. And then now we're here, our count is 2. And so it doesn't equal no, so we're going to increment count, which we did here, and then we're going to traverse the next node. So this is now going to hold 100. And then we go back to 122. Does current equal no? No, it's holding 0x100. And then we're going to increment the count, so now we're going to be at 3. And then we're going to go to current. We're going to traverse again and go to current next. Well, current next is holding the null value. So our current will now be holding the null value. So now we go back to line 122. Current does not equal null. Well, in that case, that condition is now false because current is null. So now we complete 122 to 126, And there's one last thing that we have to do. We have to return count. So in this case, 3. So this integer count nodes, when we call this function, it's going to be a 3. So let me put that up in our main and let's test our function. Printf. And then I'm going to put a new line to make it pretty. Number of nodes. Here we are going to put our function, count nodes, and then we're going to pass head to it, because now this is returning an integer value of 3. So this is returning 3. And so let me compile our function and see if it works. And there it is. So we have 40, 25, 15, and the number of nodes. Let me uncomment these. So there it is, the number of nodes 6. There is one last thing I want to do. I want to move this. I want to keep the number of codes that I have in my main function to as little as possible, just to stick with the marginalized function. So I'm going to put it on our print list function. I'm going to put it after all of this is completed, and I'm going to put it right below this. So I'm calling this function from this function. And there it is. So how this works now is, let me draw this on the, and I'm not going to go through it in detail. I'm just going to go through it in terms of how it's, and let's just say that this is commented. We call the pushhead1 function, and this is the activation record for it. And then we do stuff. So every time we call our pushhead1 function and we execute it, it's popped off the list. And so this is popped off the list. And then we go to our count node function. So we count node, and then we execute all of this. And after we do that, this is popped off the list. This is popped off the list. And then the first way we were doing it is, then we go to print and then we were printing it. But since we've added the count node, let me delete count node. So we execute our pushhead function, and then they're popped out the list. And then we call our print function, and then we execute all of this, and then our print list will call the count node function. So a new activation record is created. So this will be our count nodes function. And then we go through here, and after we execute that, it returns 3. And this right here returns the integer 3. And so when we print this, it prints the return value of 3. And so after count node is executed, it's popped off the stack. And then we go back to print list, and there's nothing after the printf. And so it prints the number of nodes. After that is executed, this is popped off. And now we're back to our main. Return 0, and then main will be popped off. But in a nutshell, that's how it's working inside the stack memory. And that's our count node function.